So P.5 factoring polynomials, J4. This is where we're going to put everything that we have learned so far in factoring together. So we're going to use a general strategy for factoring polynomials. And so this is where we're really going to apply these steps for factoring. So remember, our first step is to check and see, does it have a greatest common factor? If it does, then we take it out. Then we're going to count the number of terms and factor it. So if there are two terms, then we can either do a difference of squares, a difference of cubes, or a sum of cubes. If there's three terms, we can either factor it as a simple trinomial or an alien trinomial. And if there's four terms, we're going to use grouping. And then make sure that your step 3 is to make sure that you are factored completely. All right, so look at example 1 here. So look at A. We're going to go through our steps, and our first step is greatest common factor. Well, we have the numbers 3, 30, and 75, and they're all divisible by 3. And then we have an x cubed, x squared, and an x. So we can take out an x with the smallest exponent, which is a 1. So we're going to divide each of these terms by 3x. So first one, my 3's will cancel, and x cubed divided by x is x squared. Negative 30 divided by 3 is negative 10, and x squared divided by x is x. Positive 75 divided by 3 is a positive 25, and x divided by x will cancel. So always go ahead and check now. Inside the parenthesis there, we're going to go back through the steps. So does it have a greatest common factor? Because we could have made a mistake. We might have just taken out a common factor and not necessarily the greatest common factor. So when we look in these parentheses, we see our first term has an x squared, but not all the terms have an x in it. Then we're going to, step 2 is count the number of terms. So we got 1, 2, 3. So it's a trinomial. So is it a simple or an alien? Well, remember, an alien has the number in front of it, in front of the x squared, other than a 1. So this one would be a simple. And so what I'm also going to do, though, here with that 3x, it's part of my answer. So I'm going to bring it down here. I'm going to make an answer box. I'm going to go ahead and put my 3x in there. That way I don't forget about it. Now, back to factoring this trinomial. So we know if it's a simple, we're going to open two sets of parentheses. Our first terms have to multiply to give us that x squared, so x and x. Our second terms are going to multiply to give us 25, and then remember, read it backwards. They also have to add to 10. So what multiplies to 25 that also adds to 10? So we got 1 times 25, 2 doesn't go into it, 3 doesn't, 4 doesn't, 5 times 5. Repeating ourselves, so that's all of our options. Do either of those add to 10? 5 plus 5 is 10. So a bigger number first, even though it doesn't matter since they're the same. Excuse me. Bring down the first sign. And then remember, it's negative 5 times what kind of 5 will give us that positive 25? Well, negative times what is a positive? A negative. And then you need to check both your parentheses and make sure they're factored completely. So if you check your first parenthesis, ask yourself, does it have a greatest common factor? It does not. Then count the number of terms. There's 2. Is it a sum or a difference? It's got a minus sign, so it's a difference. But is it a difference of squares or a difference of cubes? Neither one, because the x doesn't have an exponent that's divisible by 2 for the squares or 3 for the cubes. So therefore, that is factored completely. Then check the other one. But wait, this is the same exact thing, isn't it? So therefore, we know it's factored completely as well. If it was different, then we would go through our steps. Now remember, though, because these are the same, that we could also write it as the x minus 5, all of it squared. And so since now we know that that's factored completely, I'm going to go ahead and put it in my box here with my 3x. So I have 3x times x minus 5 squared. And that's factored completely. So let's try B. B has negative 3t squared plus 15t plus 72. We don't like a negative to be at the beginning. So we're automatically, when I ask, is there a greatest common factor, we're going to pull that negative out. So then check your numbers. There's a 3, a 15, and a 72. Are they all divisible by something? Well, 3 and 15 are both divisible by 3, but is 72? Remember, there's a shortcut. If you take the digits of the number and add them together, if that number is divisible by 3, then that means that the 72 is divisible by 3, and this one is. 7 plus 2 is 9. 9 divided by 3 is 3. Therefore, 72 is also divisible by 3. So we're going to greatest common factor out a -3, and then check your variables. Do they all have a t? They do not all have a t, so we can't take it out. So we're only going to common factor out a -3. So I'm going to divide each of these terms by -3. So -3 divided by -3 cancels, but we still have that t squared. 15 divided by -3 is -5, and we still have our t. 72 divided by -3 is a -24. All right, so we got to make sure we're factored completely. So check what's inside the parentheses. Does it have a greatest common factor? It does not. How many terms? 3. Simple or alien? Simple, because there's no number in front of the t squared. All right, so don't forget about this -3. I'm going to go ahead and bring it down and put it in my answer box. And now I need to just focus on that trinomial. So we said it's a simple, so we're going to open 2 sets of parentheses. Our first terms have to multiply to be t squared, so t and t. Remember, our last terms here are going to multiply to be 24 and subtract to be 5. So what multiplies to 24 that also subtracts to 5? Five doesn't go into it. 6 times 4, we're repeating ourselves. So here's everything that multiplies to 24. We know that 3 times 8 is 24, but 8 minus 3 is 5. So put the bigger number first. Bring down that first sign. And then check. -8 times what kind of 3 gives us a -24? A negative times what gives me a negative? A positive. Wasn't an alien, nothing to bring back. So now I just got to make sure these parentheses are factored completely. So let's check the first one. Any greatest common factor? Does not. How many terms? 2. Some are difference. Got a minus sign, so it's a difference. Difference of squares are cubes. The exponent's not divisible by 2 to be squares or 3 to be cubes, so neither. So therefore, t minus 8 is factored completely. Then check the t plus 3. Any greatest common factor? No. Number of terms? 2. Some are different. It's got a plus sign, so it's a sum. The only sum thing we have is of cubes. Well, again, the t does not have an exponent that's evenly divisible by 3 for cubes, so therefore, it's factored completely. So we're just going to bring both of these down then into our answer because they're both factored completely. So we have our -3 times t minus 8 times t plus 3. And now we're factored completely. Same thing, just keep going here. So we have on A, we're factoring still, so do we have a greatest common factor? Well, they're all even. 28 and 16 are both divisible by 4, and so is 80. Is there anything bigger? I don't think so, but let's try. If we divide it by 4, and when we get to our parentheses, if it still has a greatest common factor inside of it, then we'll need to pull it out as well. That means the 4 would just be a common factor, not the greatest common factor. But what about the variables? I have n to the 4th, n cubed, and n squared. They all have an n, so we're going to take an n out with the smaller exponent, the square. So let's divide all of these by 4n squared. All right, 28 divided by 4 is 7. N to the 4th divided by n squared. Remember, when you divide, subtract your exponents. 4 minus 2 is 2. 16 divided by 4 is positive 4. N cubed divided by n squared. Subtract your exponents. 3 minus 2 is 1. Negative 80 divided by 4 is negative 20. N squared divided by n squared is going to cancel. All right, so let's make sure we factor completely. Look inside the parentheses. Does it have a greatest common factor? It does not, which meant 4n squared was my greatest common factor of the original one. All right, so no greatest common factor. Let me go ahead and bring this 4n squared down. And let's factor out our parentheses. So we already said no greatest common factor. How many terms? 3. Simple or alien? It's an alien. It's got that 7 in front of it. So this is our alien woman. She's going to go on vacation. She kisses her husband goodbye, and she's gone. She's gone, so don't write her down. Remember, when they kiss, they multiply. Now we got that simple trinomial. We know our first term is going to multiply to n squared. And our last terms here are going to have to multiply to the 140, but also subtract to 4. And so we do multiply to 140, subtract to 4. 4 is a small number when they're subtracting, so it's probably going to be a little ways down into my my first number, okay? So it's not going to be like 1 or 2. But we can go through and we can find what multiplies to give us 140, and we keep going, and we'll get 10 times 14, which does subtract to give me 4. Larger number first, bring down that first sign. Positive 14 times what kind of 10 would give us that negative 140? A positive times a negative is a negative. But don't forget, this was an alien, so you got to bring her back. He's mad. They divide by her. Reduce it if possible. And then 10 over 7 doesn't reduce at all. So what do we do with the number that's on bottom? Remember, we throw it back to the, we said x before. This is an n, so we're going to throw it and put it in front of the n. So 7n minus 10. Now on these, because they're aliens, check. What's n times 7n? That's that 7n squared we had. And that's what we wanted. Because otherwise, that's where we'll find that we've made some type of mistake, okay? If we don't bring our alien back, or if we don't reduce our fractions correctly all the way, something like that. The mistakes usually show up right there. All right, so we're done factoring that trinomial. We just got to make sure it's factored completely. So look at the individual parentheses. Does n plus 2 have a greatest common factor? No. 2 terms, it's a sum, but it is not a sum of cubes. So we're done with the n plus 2. What about 7n minus 10? No greatest common factor. 2 terms, difference because of the minus sign, but not a difference of squares or cubes, so it's completely factored as well. So I'll put them both in my answer box with my 4n squared, and that is the completely factored form. On B, starting out factoring greatest common factor. Well, 3 and 12 are both divisible by 3. Can't take any x out because the 12 didn't have an x. So we're going to common factor out of 3. Our 3's cancel, and we have x squared. And negative 12 divided by 3 is negative 4. So we know that the 3 is going to be part of our answer. And can I factor the parenthesis any further? Does it have a greatest common factor? It does not. How many terms? 2. Some are difference. Squares are cubes. Well, that x has a square, and so that 2 right there is divisible by 2, which means it could be a difference of squares. If it's divisible by 3, then it could be a difference of cubes, okay? So we think this is a difference of squares. So I'm going to remember our formula here. Remember, for difference of squares, we have a squared minus b squared. That's the problem. And then we're going to find a and b and plug it into a plus b times a minus b. Remember, because they're squares, to find a and b, we take their square root. So what's the square root of x squared? X. What's the square root of 4? 2. So there's my a and my b. So I get a, which is x, plus b, which is 2, times a, which is x, minus b, which is 2. And then check to make sure you can't factor those parentheses any further. No greatest common factor in the first one. 2 terms, sum, but not a sum of cubes. So I know that x plus 2 is going to be part of my answer. Check the second parenthesis there, x minus 2. No greatest common factor. 2 terms, difference, but not a difference of squares or cubes. So here we have the rest of our answer. So we had our 3, and we said x plus 2 and x minus 2. So that's completely factored form there. And then in example 3. Example 3, I'm going to make a change. I don't want that x cubed to be on the end of it there. So take it out. So this is the problem we've got. 16x cubed plus 16x cubed plus 54. All right, greatest common factor. Well, I know for sure they're both divisible by 2 because they're both even, so I'm going to go ahead and take a 2 out. And I have an x cubed on the 16, but there's no x's on the 54, so let's just divide out a 2. So 16 divided by 2 is 8, and then we still have our x cubed. And 54 divided by 2 is a positive 27. So check your parenthesis. Make sure there's no other greatest common factor. 8 and 27 aren't divisible by anything other than 1. So that means that 2 was my greatest common factor. So I'm going to bring it down into my answer box. And let's go look at what's in the parenthesis. So in the parenthesis there, we have 8x cubed plus 27. So we already said there's no greatest common factor. There's 2 terms. It's a sum. Is it a sum of cubes? Well, that exponent there is divisible by 3, which makes me think it might be a sum of cubes. So we need to check. Does 8 have a cube root? Well, you could either do your factor tree or you could use your calculator. But either way, at the bottom of the factor tree, you'll see it's 2, 2, and 2, which means the cube root of 8 is 2. The cube root of x cubed is x. And 27, same thing. You could either use your calculator or do your factor tree. But at the bottom of it, you'll get 3, 3, and 3, which means the cube root of 27 is 3. So this is a sum of cubes. And so the sum of cubes has the formula of a cubed plus b cubed is equal to. So here's what you're going to answer. A plus b times a squared minus a times b plus b squared. Now we already found our a and our b. We found a is 2x and b is 3. So let's go through and let's work that out. So we got a plus b times, now be careful, when they're squared, put them in parentheses. So we have that a, which is 2x squared, minus, from the formula, a, which is 2x, times b, which is 3, plus, per the formula, b, which is 3 squared, and close it. And so we just need to simplify that second parenthesis there. So I'm going to bring down this first one. So 2x plus 3 times. Now what is 2x squared? Remember, that means 2x times 2x, which is 4x squared. Bring down your minus. 2x times 3 is 6x. Bring down your plus. And 3 squared is 9. Now we got to check to make sure it's factored completely. So the first parenthesis, 2x plus 3, has no greatest common factor. 2 terms. It's a sum, but it's not a sum of cubes. So the 2x plus 3 is factored completely. So I'm going to go ahead and just bring it down. You can do it now or you can do it at the end. Now this third one is a trinomial. Now guys, honestly, I have not seen when you factor, when you do a sum or difference of squares that the trinomial is factorable. Doesn't mean it won't happen. I just can't ever recall seeing one. But we're still going to double check. So we can see it has no greatest common factor, 3 terms, and so we need to see it's an alien. So let's check. If I take the alien woman, she's going to go on vacation. Remember, you're going to rewrite this. She's gone, and they're going to multiply it. 4 times 9 is 36. So here's what I'll tell you if it's factorable or not. Remember, you're going to need 2 numbers that multiply to 36 that are going to add to 6. So multiply to 36 that also add to 6. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and 6 times 6. Do any of those add to be 6? They do not. Therefore, this is prime. It's not factorable. So since it's not factorable, that means it's completely, we're done factoring as far as we can. So just bring down your trinomial, 4x squared minus 6x plus 9. And that would be the original problem up there in completely factored form. And then for our last one here, do we have any greatest common factor? We do not. How many terms? 4. Remember, 4 is grouping, so we're going to split this in half and common factor the individual sides. Well, this left side here, they both have an x in common, so we're going to divide them both by x. We do that, we get z, and then we get minus w. And we're going to common factor the right side, but remember, we always common factor out that sign. So we're going to common factor out a negative, and then what do yz and yw have in common? A y. So we're actually common factoring out a negative y. So negative y divided by negative y will cancel, and we're going to get z. We got positive y times negative y. That's a negative 1, but remember we have that w, so it's a negative 1w, or just minus w. And then make sure what you have in parentheses is the same. If it's not, either you made a mistake or it's not factorable. And so they are the same, so that means they have a greatest common factor of that z minus w in parentheses. So take it out in parentheses. We're going to divide by it. Okay, z minus w divided by itself will cancel, so we're going to get x. Z minus w divided by itself will cancel, and we get minus y. Make sure these are both factored completely. Neither one have a greatest common factor. Both of them are two terms with a difference, a minus sign, but neither one are a difference of squares or cubes. So this is our completely factored form.